Should you use RAG or fine-tuning for your AI project? This is the most common question in AI development right now, and the wrong choice can cost you months of work and thousands of dollars. Today, I'm breaking down exactly when to use each approach, with real examples and a decision framework you can use immediately. By the end, you'll know which one fits your specific use case. RAG stands for retrieval-augmented generation. It's like giving your AI a search engine. Instead of relying only on what the model learned during training, RAG lets it search through your documents, databases, or knowledge base at runtime. Here's how it works. When a user asks a question, RAG first searches your knowledge base for relevant documents. It uses vector embeddings to find semantically similar content, not just keyword matching. Then it combines those retrieved documents with the original question and sends everything to the language model. The model generates an answer using both its training knowledge and the specific documents it found. The key advantage is that RAG is always up to date. Your knowledge base can be updated anytime, and the AI immediately uses the new information. You don't need to retrain anything. It's also transparent. You can see exactly which documents the AI used to generate its answer. This makes debugging and trust much easier. RAG is perfect for customer support bots, documentation search, research assistants, and any application where you need current, sourced information. The limitations: RAG depends on the quality of your search. If your documents are poorly organized or incomplete, the AI will give poor answers. It also adds latency. Searching takes time, and it can't learn patterns or styles from your data. It can only retrieve and synthesize. Fine-tuning is fundamentally different. Instead of searching for information, you're actually modifying the model itself. You take a pre-trained language model and continue training it on your specific data. This teaches the model new patterns, styles, formats, and knowledge that weren't in its original training. Think of it like this: RAG is like giving someone a reference book. Fine-tuning is like teaching them a new skill. When you fine-tune, the model doesn't just retrieve answers, it generates them in the way you've taught it. You can fine-tune for specific tasks like code generation in your codebase's style, writing in your brand's voice, classifying documents your way, or generating responses that match your customer service tone. The advantages are significant. Fine-tuned models are faster at inference, no search step needed. They can learn patterns, not just facts. They can capture nuance and style that retrieval can't, and they can generalize from examples, not just copy retrieved content. But fine-tuning has real limitations. It's expensive, you need quality training data, compute resources, and expertise. It's static, the model doesn't automatically learn new information. You need to retrain periodically. It can cause catastrophic forgetting. The model might lose general capabilities while learning your specific task. And it's harder to debug. When the model gives a wrong answer, you can't easily trace why. Fine-tuning is best for specialized tasks, custom styles, high-throughput applications, and when you need consistent, predictable outputs. Let's compare them directly on the factors that matter. Accuracy: RAG excels at factual questions with clear answers in your documents. Fine-tuning excels at pattern recognition, style matching, and tasks requiring judgment. Speed: fine-tuning wins, no search step means faster inference. RAG adds 100 to 500 milliseconds latency for retrieval. Cost: RAG is cheaper to start, you need documents, not training data. Fine-tuning requires quality datasets, compute, and expertise. A typical fine-tune costs $100 to $10,000 depending on model size and data. Maintenance: RAG is easier, update documents anytime. Fine-tuning requires periodic retraining as your data changes. Transparency: RAG wins, you can cite sources. Fine-tuning is a black box, you can't see what the model learned. Scalability: RAG scales with your document store. Fine-tuning scales with compute resources. Data requirements: RAG needs organized documents. Fine-tuning needs 100 to 10,000 quality examples minimum. Use cases: RAG for knowledge-intensive tasks, current information, auditable answers. Fine-tuning for specialized tasks, custom styles, high-volume applications. Here's my decision framework. Use RAG when your data changes frequently, customer support, documentation, news. When you need citations and transparency, legal, medical, financial. When you're starting out and want quick results. When accuracy depends on specific, current documents. Use fine-tuning when you need a specific output style or format, brand voice, code style. When speed matters and you can't afford retrieval latency. When you're processing millions of requests and need efficiency. When patterns matter more than specific facts. Use both when you need current knowledge and specific patterns. Enterprise search with custom response style. Customer support with brand voice and up-to-date information. Code generation with your code-based knowledge and your team's patterns. The hybrid approach is increasingly common. RAG provides the knowledge, fine-tuning provides the style. Together, they create AI that knows your stuff and speaks your language. So let's recap. RAG retrieves information at runtime, perfect for current, sourced, auditable answers. Fine-tuning modifies the model itself, perfect for custom styles, patterns, and high-speed applications. RAG is cheaper and easier to maintain. Fine-tuning is faster and can learn patterns. Use RAG for knowledge, use fine-tuning for skills. Use both for the best of both worlds. The decision framework is simple. Does your data change? Use RAG. Need a specific style? Fine-tune. Need both? Combine them. Which approach are you using for your AI project? Drop your experience in the comments. I want to hear what's working. If this helped clarify things, hit subscribe. I break down AI concepts every week. Links to all resources in the